Modern airplanes are among the most advanced machines ever built. They calculate speed, altitude, angle of attack, position, and performance hundreds of times per second. They compare data from multiple sensors. They cross-check themselves constantly. From the outside, it looks like nothing can fool them. And most of the time, that's true. But there are moments when pilots are trained to stop trusting the plane itself. Not because the aircraft is damaged. Not because an engine has failed. Not because there is an obvious emergency. But because the information the plane is providing looks perfectly reasonable and is completely wrong. This is one of the most uncomfortable truths in aviation. Airplanes don't always know what's happening to them. And when that happens, trusting the instruments can be more dangerous than ignoring them. To understand why, you need to forget how most people imagine flying works. Passengers assume pilots see what the plane is doing through the instruments, that the displays show reality. But in truth, pilots never see reality directly. They see interpretations. Every number on the screen is an estimate. Every indication is calculated from sensors. Every sensor can fail, and sometimes they fail in ways that look believable. Let's start with airspeed. Airspeed is one of the most critical pieces of information in flight. Too slow, and the plane stalls. Too fast, and the structure can be damaged. So how does a plane know how fast it's flying? It doesn't measure speed directly. It measures pressure, specifically the difference between two types of air pressure, dynamic and static. That measurement comes from small sensors called pitot tubes. They are simple devices, just small tubes facing forward into the airflow. As the plane moves, air enters the tube. The faster the plane moves, the higher the pressure. That pressure is converted into airspeed. It sounds straightforward, until something blocks the tube. Ice, insects, debris, water. If a pitot tube becomes blocked, the airspeed reading becomes unreliable. But here's the dangerous part. It doesn't always go to zero. Sometimes it freezes at a believable number. Sometimes it slowly increases. Sometimes it decreases gradually. It lies convincingly. Now imagine you're a pilot. The airspeed indicator shows a value that looks normal. The plane feels normal. Nothing seems obviously wrong. But another instrument starts disagreeing. Maybe the altitude trend doesn't make sense. Maybe the vertical speed feels off. Maybe the power settings don't match the performance you expect. This is where the human brain struggles. Because humans are pattern-matching machines. We trust the instrument that looks the most familiar. And in modern cockpits, automation is usually right. So when it's wrong, it's especially dangerous. Pilots are trained for this exact situation. There is a specific procedure called unreliable airspeed. It's one of the most mentally demanding scenarios in aviation. Because the instruction is simple and terrifying, ignore the airspeed indicator. When pilots declare unreliable airspeed, they stop chasing numbers. They revert to pitch and power. Pitch controls the angle of the aircraft. Power controls thrust. These two parameters, combined with experience, keep the plane flying even without speed information. It feels primitive, but it works. And that tells you something important. At the most critical moments, aviation falls back to fundamentals. Because automation depends on sensors. And sensors are physical objects in a hostile environment. Now let's go deeper. A modern airliner doesn't have one pitot tube. It has multiple, often 3, each feeding different systems. But what happens when they disagree? This is where things get dangerous. The plane doesn't know which one is right. It only knows they are different. So the computers try to resolve the conflict. They compare data. They apply logic. They make assumptions. And sometimes those assumptions are wrong. Now the pilot is faced with a screen full of numbers that disagree with each other. One says the plane is too slow, another says it's too fast, another is blank. This is where training matters more than technology, because the human instinct is to fix the problem, to chase the number, to adjust controls until the display looks normal. That instinct has caused accidents, not because pilots were incompetent, but because the situation violates human intuition. The plane feels fine. The numbers say it isn't. Which do you trust? This conflict is not limited to airspeed. Angle of attack sensors can fail. Altitude sensors can drift. Navigation data can become inconsistent. Modern cockpits try to simplify this with automation. But automation introduces a new risk: complacency. When systems work perfectly most of the time, humans stop questioning them. They trust the display more than their senses, until the display is wrong. This is why pilots are trained not just in procedures but in distrust. They are taught to ask, does this make sense? Does this match what the plane is doing? Does this match physics? If the answer is no, the instruments are wrong. And this brings us to one of the most uncomfortable truths in aviation. Sometimes the safest thing a pilot can do is ignore the plane. Not in panic, not emotionally, but deliberately. This doesn't mean flying blind. It means understanding which information is reliable and which isn't. It means knowing when automation is helping and when it's hurting. Aviation accidents rarely happen because of one failure. They happen because of confusion, conflicting data, unclear priorities, delayed decisions. That's why modern training emphasizes mental models. Pilots are trained to understand how the plane should behave, so when it doesn't, they recognize it immediately. This is also why older, more experienced pilots often handle these situations better. Not because they are smarter, but because they've seen more weirdness. They've felt the plane in unusual configurations. They've learned what wrong feels like. Now consider this. Every modern plane is certified to fly safely with failures, but certification assumes correct human response. The plane can survive bad data. The question is whether the crew can interpret it correctly. This is why checklists exist, not as bureaucracy, but as cognitive anchors. Under stress, humans lose working memory. Checklists offload that burden. They force pilots to slow down, to verify assumptions, to avoid chasing symptoms. Now let's zoom out. This problem isn't unique to aviation. It exists in every complex system: power grids, medical devices, financial markets. Whenever humans rely on interpreted data rather than direct reality, trust becomes a risk. Aviation just exposes it more clearly, because the margin for error is small. So when pilots stop trusting the plane, it's not because they are afraid. It's because they understand something fundamental. The plane does not experience reality, it calculates it, and calculations can be wrong. The ultimate safety system in aviation is not redundancy, it's skepticism, the willingness to question what looks normal, to step back, to simplify, to return to basics. That mindset has saved countless lives, and it's why flying remains so safe. Not because planes never lie, but because pilots are trained to recognize when they do. That is the moment when trusting the plane becomes dangerous, and stopping that trust becomes the safest decision possible.